Hello, Jaguar students. It's your friendly neighborhood math teacher, Mr. Allred, and I would like to welcome you to Unit 5, mini lesson number 2 on the distributive property. Today's learning goal is to be able to explain how to use the distributive property to simplify variable expressions. And we're going to go ahead and get started right now with these notes. This is your second entry in the table of contents. This is Unit 5, mini lesson number 2 on the distributive property. Good luck to you. Please pay attention. Please try your best to keep up with me during these notes. Here we go. All right. So the distributive property, what it does is it distributes a sum or a difference. Okay. Sum or a difference, right, means addition or subtraction. So it distributes an addition or subtraction problem. To do that, we multiply each number within the parentheses by the number outside the parentheses. Okay. Just like this, when you were first taught multiplication and you were taught 3 times 4, you were probably taught that it was 3 groups of 4. You were taught that you could use repeated addition, 3 4s added together, to figure out what 3 times 4 was. And your math teachers back then were exactly right. That's exactly what multiplication is. It's just repeated addition. So 3 times 4 is 12. Same thing here. This is 2 times x plus 4. So this is 2 groups of x plus 4. We have one group of x plus 4 here, plus another group of x plus 4 right here. So this is truly 2 groups of x plus 4. Okay. The way that we can combine those terms and put them together is we know we have one x here, another one here. We got 2 x's, and then 4 plus 4 is 8. So simplified, 2 times x plus 4 would be 2x plus 8. Okay. Now, I could certainly do that every time I had a problem with a number outside parentheses like that, and just use repeated addition to show what it was. But if I had 18 times 3x plus 7, it would take me a long time to write all that out. So there's a shortcut. The shortcut is called the distributive property. So what we do is we take the number on the outside and multiply by both the terms inside the parentheses. So if we have 2 times x plus 4, we take 2 multiplied by x, and then we take 2 multiplied by 4, and sometimes we can keep that plus sign in the middle. So 2 times x is 2x, plus 2 times 4 is 8. I've got 2x plus 8 right there for that problem. That's the shortcut, and it's called the distributive property. Okay? It works because if you look at these 2 rectangles separately, I have a 4 by 3 rectangle and a 4 by 5 rectangle. So I have an area of 12, 4 times 3 is 12, and an area of 20, 4 times 5 is 20. If I add those two things together, 12 plus 20 is 32, okay? If I stack them next to each other and said, oh, well, I know that they both have the same width of 4, one of them is 3 and one of them is 5, this is the distributive property. So instead of trying to do them both separately and doing 4 times 3, figuring what that is, and then adding 4 times 20 to it, I can do 4 times 3 plus 4 times 5 in the same step. That's the distributive property. I know that this is still going to be 32 because math is always the same, but it's just a shortcut to get there. Okay, so let's try one. I'm going to try one right here for you, and then you're going to do one on your own. 3 times x minus 6. 3 distributed to x minus 6. 3 times x is 3x, and then that minus sign is going to stay there. 3 times 6 is 18. So my final answer there is 3x plus negative 18, or also known as 3x minus 18. Those are the same thing. So I distributed that 3. 3 times x is 3x. 3 times 6 is 18. I knew that subtraction sign in the middle would stay. I knew that subtraction sign in the middle would stay because if the number on the outside of the parentheses is positive, the operation in the middle will always stay the same. If the number on the outside is positive, the operation in the middle will always stay the same. Okay? I'm going to ask you to try number B on a puzzle. It's going to ask you what it is. That's right. 4 times x plus 4 times 5. 4 times x plus 4 times 5. 4 times x is 4x, and 4 times 5 is 20, and that addition sign in the middle is going to stay the same. Great job there on number B. Okay? Things get a little dicey when we distribute a negative, but it's not that bad. When you distribute the negative on the outside, we have to use our integer rules from way back when in Unit 1. This is a throwback to Unit 1. We're going to do negative 2 times x plus negative 2 times 4. So again, negative 2 times x plus negative 2 times 4. Negative 2 times x would be negative 2x. Negative 2 times 4 would be negative 8. So I can write this answer two different ways. I can write it negative 2x plus negative 8, or I can write negative 2x minus 8. Because in Unit 1, we said adding a negative was just like subtracting a positive, if you remember way back when from Unit 1. So that's your first example on distributing a negative. I'll do one more here for you. This says negative 3 times x minus positive 6, negative 3 times x minus negative 3 times positive 6. That's what we're doing here with the distributive property. Multiply the outside number by both terms inside. Negative 3 times x would be negative 3x. And negative 3 times positive 6 would be negative 18. This part right here. There's a minus sign in front of it, however. Minus negative 18. And way back when in Unit 1, we said that subtracting a negative was just like what? Tell Ed puzzle. That's right. Subtracting a negative is just like adding a positive. Subtracting a negative is like adding a positive. Positive. That's what we said in Unit 1 anyway, and that still holds true today. Subtracting a negative is like adding a positive. So I want you to try example number 2 right there in Ed puzzle. If you got negative 14x plus 28, then you're in a good spot, okay? And you can actually all stop working right now, and you're not going to do any more math problems tonight, okay? That was just our introduction to the distributive property. We'll, of course, do a lot more in class tomorrow to try to understand this even better than we do right now, okay? Make it a great day or not, the choice is yours. And please remember, of all the students I've ever taught, you are one of them. Thanks and have a great day.